welcome to Plutus IAS, and today we are covering the trans effect, which is most often used for the ligand substitution in square planar complex, which is used for ligand substitution in square planar complex, square planar complexes. So now, trans effect we already know. Its work as that whenever you have a ligand, if I want to substitute a ligand, and let's say if I have a ligand which is capable of, which has a very strong electron donation tendency, it can, if I am adding a new kind of ligand to it, the new ligand will come at a position which will be in opposite direction that of the ligand which is applying the trans effect. B. Now, this is very common how trans effect is happening, but we need to explain the actual science behind it. So, to explain trans effect, there are two theories that are most often used. First is called as the electron polarization theory. Electronic polarization theory, which is also called as thermodynamic trans effect. Then the next one is called as your pi bonding theory. Pi bonding theory for trans effect, which is also called as the kinetic trans effect. Kinetic trans effect. Now, both of the theories are trying to explain what is your trans effect, but the thing is, electronic polarization theory has a limitation. If I look for the trans effect, ligands such as cyanide, nitrosyl, they come at a much higher power in applying the trans effect compared to H minus, CH3 minus, and pyridine, NH3, and H2O like species. Okay? Now, what does the electron polarization theory states? So the electron polarization theory states that if I have a complex in the square planar arrangement, and if I have a ligand which has a very strong polarization tendency, that means it can easily distort its electron cloud and push electron density in the direction of metal. If this happens, since every single metal has a tendency to have a definite amount of bonding with all the ligands, then it reduces its share of electron with the ligand which is in exactly opposite direction to this trans ligand, which leads to increase in the bond length of this ligand, or we can also state that this bond is now weakened because excess amount of electron density is coming from this side. Hence, any incoming ligand, can easily and preferentially attack the metal from the direction of this ligand having a weaker bond. Hence, later it will take its place and will form and will add trans to the ligand. Now, this theory is very good, but it is applicable only to the ligands which are polarizable. For example, Cl minus, I minus, Br minus, let's say somewhat Cn minus, SCn minus. But this theory cannot explain the strong pi trans effect of ligands which are neutral. For example, carbonyl and nitrosyl, which have covalent bond in them. So, the thermodynamic theory fails at this point. So we require a more reliable theory to explain the phenomena that we are getting in trans effect. So this theory takes into account that in a square planar complex, if we have a ligand which has either empty pi star or sigma star orbitals which are capable of accepting electron pair from this metal center, they will have a higher trans effect. Now, to explain this, the pi bonding theory assumes that the reaction is going through an associative mechanism. That for the complex to be substituted, first the nucleophile, that the ligand that we are adding, it will attach itself to the metal center, converting it to a trigonal bipyramidal type of geometry, where its coordination number will increase. Now, since this new ligand is pushing its electron density towards the metal shares excess amount of electron density from its filled pi orbitals to the pi star orbitals of the ligand, for example, carbonyl or nitrogen. Here, that means the bond in these directions is very much stabilized in a single line. The B ligand is providing electron, metal is providing extra electron density to the A via pi back bonding. So the bond in these directions are very much strong. Hence, now the B will remain in this direction only. Now, since the steric requirements are very high, there is large repulsion. So any of the ligand can easily remove, and we will get the ligand A and B in opposite direction preferentially. So the kinetic theory of trans effect explains how the trans effect is going through and why carbonyl or nitrosyl type of ligands apply high trans effects. So this was all about trans effect. I hope it has cleared all your doubt. In case of any doubt, you can add it to the comment section and we'll get back to you. Thank you for joining us.